Now let's learn about big data analysis, data warehousing. That why data warehousing is so important. So we will learn what is operational versus analytical queries on data. We will also learn data warehousings and data maths, architecture of data warehouse, format of data in data warehouse, and in the end we will discuss ETL, process for building data warehouses. So what is traditional role of databases? So was to store operational data? Are we using databases for that? Data generated by daily routine operation within business process. Example selling, purchasing, billing. Anything we do, the data get generated. Now that's a traditional way. Usually in different businesses, there is a different sort of data. For example, if it's a music shop, there will be a data stored in terms of the customers and products, that what product we have, what customers we have. But every business got different data. So for example, this is the ID, product name, sorry, type, brand, quality, quantity, price. Now this data is linked to period or the products which we have. So for example, if we pick product 3, Gale 3040, that's a speaker type. Gale is the brand, quantity is 5, 100,000 is the price. So for example, product 3 is Gale 3040. Product 3, customer number 2, date was 3rd of 1st 2019, quantity they purchased was 1, total price they paid this much. Now who are these customers? So in that case, the third customer or second customer. So product number 3, which is Gale 3040, customer number 2. So this is customer number 2, Fred Flintstone, age 52, and that's the postcode. Now operational databases, let's discuss that. Usually stores current information. They are optimized for quick updating and performing of fixed operational queries. That what is the quantity of product A in the store? What is the cheapest product of type T? What is the revenue for today? High performances, small number of record access, database size is in MBs. Now if we take example in broader form, that business which we running in one store can be in different area. Then every area will become a key. And that data will belongs to that area. So over here we are discussing 4 cities. So if you have a business in 4 different cities, every city will have their own database. Now strategic planning from this. Quantity and evaluate contribution from each of the store. That what product they are selling across all branches. What are the trend in last few years. Find the total value, revenue for all customers in one branch over the last month. If we want to open a new store, what product should we have based on our demographic of the area? So this is what we can compute based on the database which we have. We can also analyze data from all branches, like huge volume of data, like which product we are selling most. We can also need historical, just the current data, because the historical data will help you to understand where the business is trending, which product is important. For example, just before every Christmas, you sell MP3. So That's a historical data. You need it. Queries can be highly customized, may involve information not in databases like flat files, spreadsheets, etc. We are only interested in querying the data, not modifying it. Now, what was the total revenue for all stores last month? This is one query. How we can get that? We just take the total revenue from all the stores, add them up, and do the comparison. What was the total revenue? We can do a query get total revenue for the last month from all the stores. Merge the result of the queries. Now let's do the query driven approach. When a query is issued, use metadata dictionary to translate the query into appropriate queries for individual heterogeneous sites. Map these queries across sites. Integrate the results into a global answer. Need complex integration and filtering process? Very efficient and expensive. Mix operational and analytical queries increases the load on databases. But the problem is even deeper. Operational databases are transactional, optimized for data insertion and updating. Sophisticated method for guaranteeing the consistency of transaction. Do we really need all the analytical queries? So for example, what if all the data coming into the same information? In that case, we can do update driven approach. The information from multiple heterogeneous sources are integrated in advance and stored into a warehouse. This information is available for direct querying and analyzing, the core of data warehousing. So we have one database, one database, one database, one database. What we have done, we have created an information database where all the data coming in storing, and this is a data warehouse. So let's learn the definition of what is data warehousing. It's a separate analytical queries from operational queries. We call that OLAP or OLTP, online analytical processing or online transaction processing. Build a new information repository that integrates the data coming from different sources and make it available for analyze and evaluations to support planning and decision making. Data warehousing is a collection of methods, techniques, and tools that support knowledge worker in decision making by transforming data into information. What are the requirements for data warehousing? Easy access for non-skilled user. Data integration based on the model of the enterprise. It should be flexible queries capabilities. Synthesis to enable target and effective analysis. It should be multi-dimensional representation of the data. There should be correctness, completeness, and freshness of information. Data repository that support data warehousing. Subject oriented, it should be time variant, non-volatile, and should be integrated. Now, what do we mean by subject oriented? It means data is organized around subjects. For example, customer, sales, product, information based on it. Time variant. All data is time stamped. When the data was arrived, which date, which time, which second. Non-volatile. Previous data is not erased when new data is added. Integrated. Data integrated from heterogeneous sources, relational databases, spreadsheet, flat files from everywhere.